Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on the momentum equation. In our previous lecture, we already derived the equation for the momentum equation, and we have seen that what is the force in the x direction and what is the force in the y direction. So here I have taken a question. A 40-degree reducing bend is connected in a pipeline. The diameter at the inlet and outlet of the bend is being 60 centimeter and 30 centimeter respectively. Find the force exerted by the water on the bend if the intensity of the pressure at the inlet of the bend is 8.829 Newton per centimeter square and the rate of flow of water is 600 liter per second. So these are the data that are given in this question, and though you can see the question is, reducing bend pipe is connected in a pipeline. So immediately what we'll do, we can draw a diagram of bending pipe and which is connected to a pipeline. This should be like this, Yeah. Here, if you see, we have, the diameters are different here is given. Okay. Like this, like that you can draw it. Okay. Now, the angle of this reducing bend is given 45 degree. And the diameter at the inlet, suppose this is the inlet condition of the fluid. Okay. And suppose this is connected to this pipe, and this is going to be connected. Another pipe is there, suppose here. Okay. Now suppose another pipe is there, it's connected from here to here like this, bending pipe is there. Now this angle is given. So as I told, there is a flow is there in this, and what are the data given? Let's see. Theta is given 45 degree, and the diameter of the inlet. Yeah, I'm talking about the inlet. So this is the inlet of this pipe, and this is the outlet of the pipe. Okay. Now inlet of the pipe diameter is given, that is D1. Suppose D1 is given 60 centimeter. So 60 centimeter, let's convert into meter. So you can write 0.6 meter. And from here we can find out the value of area at the section 1. So that formula is pi by 4, and this is D1 square. Okay. Similarly, 30 centimeter at the outlet of the pipe. At this point, 30 centimeter, that is we can write D2. Similarly, I just write 30 centimeter. And here we can write 0.3 meter. And again, just we can write A2 equal to, we can write down pi by 4. And this is D2 square. So let's solve this. Yeah. Now, what are other data are given? We need to find out the force exerted by the water. I'll tell you the formula for that. And before, the intensity of pressure at the inlet condition. So that is nothing but P1, intensity of pressure at that inlet condition. That is 8.829 Newton per centimeter square. So this also we can convert into meter square. So that is nothing but 8.829 into 10 to the power 4. Newton per meter square. Okay, and remaining things also you can find out from here, that area value, and area equal to, here you can write, yeah, pi by 4, that is nothing but 3.14 into D1 square, that is 0.6 into 0.6, and whole total divided by 4, so 0.2826. So this one you can write 0.2826. This is meter square. Okay. Similarly, here also we just can write the value 3.14 into D2, how much? That is 0.3 into 0.3 whole divided by 4, 0.07065. 0.07066, suppose, meter square. Or you can write 7 also. Now this is the P1 value is given. Okay, so we got most of the value here. And one more thing also, the rate of flow Q also given here. 600 liter per second. So what we need to calculate, we need to find out the force exerted by the water. So if you remember the force in the x direction, what we derived in our previous equation, that is nothing but rho into q, and you can give a bracket here, square bracket, that is v1 minus v2 cos theta, and this bracket close, plus p1 a1 and minus p2 a2 cos theta. This was the formula of force in the direction of x. Okay, the force exerted by the water on the pipe end, that only we need to find out here. Okay, this is one thing. And Fy similarly we have calculated, or we have derived, that is rho q, and this is bracket start, and here we got v2 sin theta, minus, here we just write p2 a2 sin theta. So this was the equation for the force in the y direction. So these are the two things force we have. Now why I have written this formula here, if you know the formula well and good, or else then you need to go for the derivation again for the pipe end. Now if you see in our data, what are the values are given? Let's see. V1, is it given? No, I'm not getting any V1 here. And next, what is there? Area. So A1 given, A2 given, P1 given, pressure 1 given, and theta value given. And mostly P2 not given, V1, V2 not given. Density value we know, Q also given, and this is 600 liter per second. This one also you can convert it, 0.6 meter cube per second. Just to divide in that, in the liter, just to divide 1000, we'll get this one. Now, what is the things we need to calculate from here? V1, V2 and P2. These three things we need to calculate. So V1, V2 is easy to calculate because area A1 and A2 given and Q also given. So we'll put the value of that continuity equation, or the rate of flow discharge equal to, we can write A1 V1. So here we can calculate the value of V1, that is nothing but Q by A1 here. So Q is nothing but 0.6 and divided by A1 is 0.2826. We'll get the value of V1. Similarly, V2 equal to, I can write again 0.6 divided by A2. A2 is 0.0707, I can say. This is the value. So let's find out how much is there. 0.6 divided by 0.2826. So this is nothing but 2.12. So 2.12 meter per second. This is the velocity at the inlet condition, and velocity at the outlet condition. Again, similarly, here if you see, what I'll do, 0.6 divided by 0.0707, 8.48 meter per second. We can see here diameter is more, that's why less velocity, and here diameter is less, so that's why you got more velocity. Now these two things we found from here, now V1 also we got and V2 also we got. Now the term is P2 required here. The P2 term, pressure term, because P1 is already given. Now P2 term, where we can find out any equation is there from that. Okay, then we can go for that. So as per my knowledge, we can find out the P2 value, okay, from the Bernoulli's equation. So for the Bernoulli's equation, what we need to do? We need to consider two different sections, section 1 and section 2. Then we can apply the Bernoulli's equation in the pipe flow. See, whether it is a straight pipe or horizontal pipe or vertical pipe or inclined pipe, we can apply the Bernoulli's equation in this, and we can just put the value, like what is the force acting at this point, pressure force, and what is the reverse pressure force which is acting on this fluid. And see, so we already have derived this one, correct? This kind of equation already have derived. So this is the angle of theta, which is given already 45. Yeah, now this is our diagram. Now the next thing is we need to apply the Bernoulli's theorem in this equation. So we know that P1 by rho g and plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. Okay. Now, if you see this, flow of this, so the value need to be considered here. Okay, like how the flow is moving at this point, and for this equation, let's consider the value of Z1 and Z2 both are same. The datum line, the datum value. Okay, for this equation, let it is equalize. Both are same. Now, if both are same, then what we can get the equation? P1 by rho g and plus V1 square by 2g equal to P2 by rho g, and this is V2 square by 2g. Now, if you see this equation, every values are given to us or known to us except the P2 value. So what we'll do, we'll keep this P2 one side, and remaining all the value will take it to one side. So let's go over to the next slide. So what I'll do, I'll just put the value of this P1 by rho g and all this. P1 equal to this one given. Okay, let's see. P1 equal to 8.8. Some value is there. I am not getting that one, so you can write just directly like this. And rho is 1000 is there rho, and g is 9.81. So this is the value of P1 by rho g plus V1 square by 2g. V1 square by 2g. V1 is how much we got here? 2.12. So that is V1 square 2.12 into 2.12. This is V1 square by 2g. 2 into g, that is 9.81. This is one side. And other side, if you see P2 by rho g. P2 we need to calculate. So we don't know the value of P2. And this P2, we just keep it like this. And here we can write 1000 into 9.81 plus here also V2 square by 2g. So V2 value how much? 8.48. So 8.48 into 8.48 divided by 2 into 9.81. Now if I keep all this value here one side, and I'll write just P2 by rho g equal to, this is one value, this is plus this, and this minus of this value will get. This will take this side, then will this whole total minus of this, we can do it. So now we need to solve all these values, and let's find out what is the value we are getting. And so it will take some time to solve it. 8.82 into 10 to the power 4. So yeah, this one divided by 98110. So 8.99. So we'll get 8.99 plus, and this is how much will there? 2.22. 2.12 into 2.12 and divided by 19.62. 19.62. 0.029. 0.229, and this value I'll take it this side, so it will get minus there. So how much will be there? That is 8.48 into 8.48 divided by 19.62. 19.62. So this is nothing but 3.66 some value. So anyway, how much we are getting now? If this is 9 point something, we'll get, and minus this one, So mostly we'll get near about 5 point something, 5.5 I think, 9 and 0.229 this one. So near about 5.5 something will get this value P2 by rho g. Now because we require the value of P2, so P2 I'll keep it here, rho g I'll take it to this side. So again you just need to multiply 1000 into 9.81. So again we'll get a value in about 5.5. so let's calculate this. 5.5 into 1000 into 9.81, so 53,955. okay, so this one we are going to get, this is pressure value. So this pressure value what we got here in terms of Newton per meter square. If you want to write, then you can write 5.39 into 10 to the power 4 Newton per meter square. Okay, so we got this value. Now what we need to finally calculate, we need to find out this force in the x direction and in the y direction. Now directly we'll go to this equation because all this value we got. So Fx equal to, I can write rho value, rho 1000 and q 0.6, rho q1, v1 v2 cos theta, and this is v1 is nothing but 2.12 and v2 8.48, I hope 48 cos 45. okay, and this is one term, plus here we'll get p1 a1, p1 is nothing but is already given in the equation, 8.829 into 10 to the power 4, 8.829 into 10 to the power 4, and a1, area a1, this one 0.026, so that is nothing but a1 0.2826 minus p2a2, correct, p2a2 cos theta. So p2 we got just now 5.39 into 10 to the power 4, and a2 that is also very less, 0.07 I think, 0.0707 I think. Initially we have calculated this, correct, into cos theta, cos again 45. Now see, this much equation is there, this much big lengthy equation is there, we need to solve it. Now this first you identify this value, then here we can identify one thing, then here again we can identify one more. So three parts are there, so you'll get three values, and finally you can find out the value of fx value. Okay, now here all these values are there, we can find out the value of, if you want to find out, suppose cos 45, cos, if you give here this one cos 0, so you need to give first cos, then put the value, it will give you the in terms of value here 0.707 and into 8.48. okay, so this is 5.9. now we'll get a minus value here because 5.99, this one 5.99, 2.12 minus 5.0, so we'll do 2.12, so 5.99 minus 2.12, 3.87, that is minus 3.87. okay, minus 3.87 into 1000 into 0.6, so minus 2322. so something will get near about that value because I have not taken some values, point values, 23, so minus 2322. similarly again we will get this value here, let's find out. So similarly 8.829 into 1000 into 1000, not 10 to the 4 is there, one more 10 into 0.2826, 24,950. This is some more value. 24,590. Sorry, 950. This is 950 point some 5 is there, suppose. Now the next value is, that is minus, again cos 45 is there here, and multiply of this one. So that also you can again do, will do it. So I'll go for 45 again, cos 45 this one, multiply of 5.39 into 10 to the power 4 into 0.0707, 2694. 2694 I got? Yeah, something we'll get like this, 27. Let's write 2694.5. Now you solve this, we'll get the value of fx here. Okay, so 24,000 minus of minus these two. So 2,300, here 2,600. So that means 5,000, some minus will be there. Okay, so we'll get something 19,000, some value, 90,000 something, we'll get this much Newton. So this is the value of fx. Okay, now similarly, again we need to find out the value of fy. Fy also again same thing, equation is there, rho q, again 1000 into q, 0.6 whole bracket start, and this is v2 sin theta. Sin theta again 45. So v2 value we got 8.48. So this is 8.48, and this is sin 45. Sin 45 minus p2a2 sin theta, minus p2 we got here just now calculated, 5.39 into 10 to the power 4, p2 a2 multiply 0.70, sorry 0707 we got a2 into sin 45 again. Okay, so here also we can solve it, we can find out this value. Let's calculate immediately. So again what I'll do, sin 45, this is sin 45. Yeah, same thing we'll get actually, 1 by root 2, that will be there. So multiply of, so this is minus value, correct, minus of this one. This is 8.48 I hope, multiply 8.48, yeah, 5.99 into again 1000 into 0.6. So again 3597. So 3600 we got near about for it. Yeah, we'll get something value here, 3000, suppose 600. Average value I'm writing here. This is minus of something. Okay. Now again minus of each value is here. So again if you solve this, we'll get this equation, sin 45. Let's write this, sin 45 again multiplication of 0.0707 into 5. Suppose 4 is there into 1040, 2699. So we'll get someone, suppose 2700 some value we got. So both of my negatives are there, and I will get 3600, here's 2700, so 5000, 6300. So we got this value of minus 3600. Now if you see this negative value, that indicates that the force or the flow of this in this y direction is negative. Okay, this negative sign indicates that you know, the flow is moving in the downward directions, or for the force Fy is acting in the downward direction like this. Okay, this force is acting on the downward direction. So this is the value of Fx and this is the value of Fy. Now as per the question, find the force exerted by the water, so on the bend. So you got it, Fx and Fy. Now suppose in the question it will be given, you need to find out the summation or like, you know, resultant force, and you need to find out the magnitude of that. there we could have calculated like FR, and suppose 10 5 we need to calculate, means we can go for that. Okay, so this is not asked in our question, so up to this we can solve it. So I hope you understand for this question how to solve this, and if you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.